Okay, so hello again. As said, maybe I can repeat. This talk is about system and configuration extensions for image-based Linux and beyond. It was prepared by Manja Gönker. It's a colleague who is currently not here, and me. And because she's not here, Luca Bocassi will replace her.
Thank you. So we are both, me and Manja, in the Linux Systems Group at Microsoft. We work on the Azure infrastructure. Unfortunately, she could not be here because the company didn't have budget for her to travel from the US. So I'm taking over. I'll be just reading slides, but she did most of the work on the slides with Kai, so she deserves all the credit with Kai. So thank you.
Yeah, and I also work at Microsoft in the Azure Core Linux org. Okay, so what is this about here? We start with motivation for extension images, then we introduce how this concept is provided by systemd, sysext and confext. Then we go more into detail and show some examples and usage considerations following the properties that we present. And then we go into use cases from Flatcar Container Linux and Microsoft Azure Boost, and go into future improvement ideas. So where do we come from? When we have an image-based Linux, like Flatcar Container Linux is, for example, we suddenly face new challenges, and that's why we kind of looked for solutions, and in the systemd project this idea came up for extension images. And so basically the main point is that we want to customize an image-based OS with host-level software or configuration. And then we want to manage this software or configuration through the lifetime of the machine. And the regular approaches that you have maybe is that you create files, maybe through Ansible even. And then these files, they end up in etc or /opt. And so you have scattered files, and you realize, okay, they are not really easy to update because you have to keep track of all of them. And there's a lingering file that you introduce, but it's not cleaned up. And you're also limited to simple changes then, because you can't change /usr in an image-based OS when it's read-only. So what you might end up with is building a custom image, and that is, of course, a time-consuming and impractical step sometimes. And what we rather want is that we have atomic updates. When we make a configuration change, it should be applied all together at once. And if we kind of update the configuration, we also want the old stuff to get away immediately. And what we also think is good is that we have a way of verifying what we actually deployed there. With, for example, cryptographic hashes and other mechanisms. And a second motivation is that sometimes you would just want to deploy a quick fix or debug settings, even transient, not written to disk. And this is very much the case even for traditional Linux distros, where you want to change something, deploy something without having a permanent impact.
Okay, so let's look at how sysext work. But first, point of order, we have people standing and there's 3 seats, so please squeeze in, folks. 2nd row, 3rd row, 4th row. Please defrag so people can sit. Thank you very much. Okay, so what is a sysext? A system extensions. So they are discoverable disk images or DDIs. You can stack multiple of them, and we build an overlay FS, or read-only overlay FS, and so you can we mount it atomically in one operation after it's been prepared. Using this requires a few things as a prerequisite. So you need to have a merged user. So if you are still in one of the couple of distros that don't have a merged user, which means you still have bin and lib as directories rather than symlinks, you cannot use this, but it's time to move on. Even Debian got there, right? Finally, kicking and screaming while we got there. So it's time to move on that. The hermetic user concept means that the OS vendor files all ship in the user hierarchy, and programs delivered there needs to be able to deal with an empty /etc. So they need to have sensible defaults in their programs if there is no configuration files. And this is the standard method used by libconf, by SUSE, or by systemd and all the systemd tools. So a sysext works on /user and optionally /opt for third-party vendors and allows to extend these file system hierarchies. The context is exactly the same, but for /etc. We have separate concept for this because the methodology to use them and the tools are different, and they can be deployed by different owners. One is for software owners, OS vendor or third-party software owners. The other is for the orchestrators, deployers, administrators, local users. So sysext is a bit older. Confex came in systemd 254. So these are intended to be purely additive. So you're not supposed to mask or remove things in this, although overlayfs does allow you to do that. Now, we don't enforce this. We just document it as best practice. If you know what you are doing, you can try, but our suggestion is to just use them as additive things. Now, the most important thing about extension images, both sysext and confex, is that they support the mVerity as a first-class citizen, because it is fundamental when loading images in an environment where security is important to verify and establish trust before use. Because the kernel file system developer tells us all the time, file system drivers are not safe against rogue file system images. So if your superblock has been tampered with, all bets are off. The kernel will not protect you on that. The kernel maintainers will not guarantee anything. So we signed the mVerity. The kernel established trust via cryptographic signature on the mVerity root hash before loading the image. And confex and sysext supports this both with standalone squashfs or EOFS image files or with DDIs, so GPT partition tables. Now, this was asked in the previous talk, the one previous to the previous talk, about how to verify, how to add your own keys, how do the trust chain works. So by default, the kernel has a trusted keyring, which is built in. So your Debian certificate is in the trusted keyring by default for Debian kernels. Same for Fedora, Ubuntu, and so on. That is fixed. Now, there are some kernel configs that can be added. This requires a kernel from last year or so that make it so any certificates that is stored in the UFIDB or the mock is the shim-owned local machine owner keys database. So you can add your own local keys locally on your laptop in mock. If you have certificates in DB and mock and you have the right kernel configuration enabled, and I made sure that all the mainstream distros have them, so recent OS versions from Debian, Ubuntu, Fedora all support this out of the box. The systemd readme lists the exact kconfig. If you are different distros, please have a look and enable those options. But this means those certificates will be put in the machine keyring, and that will be linked to the secondary keyring, which will be used to verify verity, which means you are not tied to the OS vendor for verification of the mVerity, but you can supply your own certificates. Now, this system extension DDIs can be used to extend a variety of things. The host file system is one of them, and Kai uses this extensively in Flatcar, but it also can be used for individual systemd service units. There is an extension images option you can add. You can just specify any sysext or confex in there, and it will be applied to that service unit in this private mount namespace. Also, we support it for the initrd. I think Leonard mentioned this earlier. You can drop a sysext into the ESP, and then systemd stub will pick it up, pass it over, and it will be used to extend the initrd. Again, with the same verification, with the same mVerity chain of trust, which is the fundamental thing. And as I already mentioned, this can come from different suppliers, either the OS vendor, or third parties, or even end users.
So that was kind of the high-level intro, and he will now continue with showing.
So again, this supports disk images, so DDIs with the GPT layout. Already mentioned this, and again, sysext is only for /user or /opt. and convex only for /etc. So this is the important thing. The other important thing is that, well, these are things that we just overlay on top of your /user or the unit /user. How do you ensure compatibility, for example, with the libc or libssl or whatever that your base OS ships and your extensions? So we extended the OS release specification so that there are specific fields that you can add in the OS release to specify compatibility. So we have a sysx level new field that you can add to your OS release if you build your base OS. Or you can also use the standard ID and version ID that are pre-existing. You define those as always in your host OS or base image /user lib OS release. Your sysx will ship a new extension release file. This is actually the one thing that identifies a sysx or a convex, the presence of userlib extension release.d, extension release.image name. There's a link here. The slides should be available on the speakers page, and these links are clickable with and bring to the specification. So in that file, you define compatibility. So your host OS has ID Debian, version ID 10. Your extension release also need to have ID 10 or version ID 10, otherwise we will refuse to load it because it's incompatible. And again, you can do a bit of mix and match, and you can just specify the ID if you have something that works everywhere, and I think you will cover this later. So we discover, for the host OS extensions, we auto-discover from a bunch of locations that are listed here, and we auto-load them early at boot after the initrd stage. As mentioned before, the bootloader, sdstub and sdboot also can discover and pass them over. And an important thing that was added by Leonard, I think in the beginning of the year, is the ability to define a policy. So you can say something like, only allow signed dmverity extensions. Because the signature is optional, you cannot ship it, but when you're managing a machine, you might want to say, actually, on this machine, only load signed dmverity and refuse everything else. This is a generic DDI policy. This is defined on the systemd man pages.
Okay, so how do you use this? These are actually CLI tools, so systemd sysx and systemd convex are the CLI tools, and they have subcommands. So the first one here shown is merge. It will search in the mentioned directories for all available extensions, check if they are compatible, and then mount them on top of /usr or opt for sysx or /etc for convex as stacked lower tiers in an overlay mount. And then if you use merge with the force flag, it will skip the compatibility checks. So even if there's no extension release file, things get loaded. And unmerge unmounts this overlay mount, and refresh combines unmerge and merge. Status shows the merged extensions, list shows all available extensions. And actually, you don't really have to do this manually because there's already a systemd sysx.service unit and a convex.service unit that automatically do this for you.
And I forgot one thing that I should have added to that slide. My apologies, I already mentioned it, but that is for the host OS. For service units, you can just say extension images equal and point to them, and that applies only to a service.
Yeah, so that's what this slide here shows. For the unit, you can use these settings, extension images, or directories if you have a directory actually and not an image file. So this image file ends with .raw. So in our example here, we have a git.raw extension that brings in the git binaries. And that means our service unit can say extended images is this git.raw image, and then exec-start can already use the git binary from this extension, even if the host doesn't have it around. And similarly, for portable services, you can kind of bring in new binaries into this portable service, for example, or even more interesting, maybe configuration under etc. And that's done through this portable CTL attach -- extension flag, where you give the extension in for your portable service image. Okay, so what actually goes into this image was mentioned before. We have to somehow match for compatibility so that these images are actually safe to load. That's this extension release.name of the extension file. For sysx images, that's under the userlib extension release folder, and then for convex, that's etc extension release.d. And the extension release file follows the common OS release file you might know from /etc. It has just some additional fields, and during merge, the image release file is compared against the base release file. So in the host case, that is /etc OS release, but in the case of portable services, then of course inside the portable service, we have the base image where this is looked up. And as was mentioned, there's mainly this ID field. It's about the OS, so that's, for example, Debian, Fedora, whatever. And then we have optional, you can use convex level or sysx level. That's something you have to define on your own with own semantics. And then we have the version ID. That's, for example, the Fedora version 39. And then you say you kind of depend on this being there. Or, yeah, architecture, it's like AMD 64, ARM 64 with special identifiers. We have to look them up. And yeah, these must match if they are defined, but you can kind of opt out with _any. We'll show that. And we are in the process of adding more fields. So one recently added was extension reload manager to kind of indicate, okay, when this extension is loaded, I actually need a live reload mechanism for the systemd service manager to pick up my drop-in files or something like that. So that's now also possible, but the story is not complete yet. And yeah, so actually your content that you ship, we have to talk about them, because when you have binaries that link to the OS libraries, then of course you have a dependency. And normally that means you now need a strong coupling with the version ID, for example, that you say, I expect this libc to be around, so I want to be on that Fedora version as base image, for example. And yeah, this also means that when you update your Fedora, then you also have to directly in lockstep update your extensions, or things won't work anymore. So what you can do instead is choose static linking, or for example, a custom library path with the linker argument where you can configure this. And then your extension is actually independent from the base, mostly. Like you can kind of assume, okay, I have some kernel features that I want to use, but yeah, basically it's a good idea to not assume too many things about the base system. So some examples here, the most minimal sysx I came up with is the following, where we have this directory tree. We have a USR folder. Maybe you prepare this on your home dir, and then you create this lib extension release d, and then extension release.myx file. Myx is the name of our extension, and inside this OS extension release file, we want to specify now what compatibility we are looking for, and we can say ID _any, and that means no assumption made on the base system. And then we can ship our file in user share myx, for example, hello world. And now when we move this folder under etc extensions as a folder myx, then already we are done. We can load this now, for example, with systemd sysx refresh. Or maybe the next advanced step would be to bundle this up as a single file system image. It's also quite easy. For starters, you can use make squashfs, and then you can move this myx.raw file into the etc extensions folder and load it, and check that your file is there.
So another example for context, the first one, you can simply extend the coredump.d.conf, so you ship a drop-in. In case you're not familiar, systemd tools support the drop-ins concept, so you can add individual configuration files that add to the default provided ones. And this example here just shows, again, the ID any, so you don't match on anything because it's a standard config available everywhere. And you say, to coredumpd, don't process core files larger than 6 gigabytes. Another example is specific to initrd. You can extend any units here. Now, as the note says, you will have to do a demo reload after this, and we are working on improving this and making it a bit more automatic. But for example, you can export a new environment variable that says log level equal debug.
So yeah, we introduced some of these properties. So what follows from them? Yeah, extensions should be fully additive, that was mentioned, and you shouldn't remove a base file with overlay fx tricks. I mean, that's possible, but that's not the way it was meant to be used for now, at least. And as I mentioned, if you don't really update the extension in lockstep with OS, then you better choose low coupling through static binaries. And yeah, then how do you update your extension? You can script this on your own, or you can also use system-to-sys-update and define a new component for your extension, and then you can kind of say, I want to be on that version, or I want to update to the latest version, and so on. I can also show this later. Yeah, extensions, or maybe you can also use portable services instead. So it's always good to check on your use case. If you have complex dependencies and so on, then portable services is a better approach because you can bundle a whole OS image like a container in the end. And yeah, then ship your service units through this mechanism. It's maybe the better choice sometimes. And yeah, caveats. So currently many early boot settings are not applied if you use system-to-sys or convex because these extensions are loaded too late. Or if you live reload, these settings of course will also not be applied. So you have to use many workarounds if you want certain settings to be applied. And for example, I will show one where you can start a service when you load an extension with upholds. And yeah, so the software in a sysext image kind of can only assume that files under /usr will show up that it brings, but it can't really rely on etc files. So if you want to have any files in etc, because your software doesn't support looking in /usr for config files, you better change your software. And if you don't do this, you will have to have many workarounds. And so convex sysext, what should you use? Use sysext for binaries and scripts, because in convex the default is to use mounts with no exec. And yeah, also if you use images that end up in an overlay mount that's not your normal host OS file system, suddenly you have to check whether things will work with SE Linux and other Linux security modules like IPE, and whether the policies will disallow execution or something like that. And yeah, when possible, always consider that you should build extension images with DM-variable protection. You don't have to, but it's a nice idea, and suddenly many things are possible. Okay, so here's one of these corner cases. Imagine you have an extension with some CLI binaries, but also a service suddenly that should be running. So what you can do is, for example, that you specify this extension reload manager setting in the extension release file. And now, in this example, our goal here is that we want systemd OMD to be running. And normally, a service is enabled through the symlink that gets created when you run system control enable, and that's the regular .once link you can find in the multi-user target.once folder, for example. But here instead we use .upholds, so that's something new. And it's different because once is a dependency that is only evaluated when the target starts, and upholds is always evaluated. So as soon as the system sees your service unit you want to run is not running, it will start it. So that's what we need here, because we suddenly bring in this new dependency to our target that's already running, and then we expect the target to kind of uphold that our service is running. So that was one of these corner cases you run into. And yeah, so more about the usage in Rebuild.
And so, yeah, myself and Mania work on Azure Boost. I have a talk about this tomorrow afternoon, so I won't go into many details. Please come to that talk if you're interested. But in a short few sentences, we use portable services mainly. So if you're not aware of portable services, they are really awesome. You should check them out. We have systemd.io portable services documentation. Basically, it allows you to take a service unit and put it into an image and ship it to any OS running systemd. And then you attach it to the system with portable.ctl, and then it runs as if it was a service that was shipped with the OS, but it actually is running on the image. Now, this used to only support one monolithic image. For the Azure Boost cases, we wanted to have a separate common base image that the OS team, i.e. me, supported with the libc, OpenSSL, and whatnot, that we can manage and service and fix CVs and whatever. And then our users just shipped their daemons or binaries or their service-specific stuff. This wasn't available, so we added this, and a bit of an anecdote. So the whole SysX concept started exactly for this use case, and we came up with it at FOSDEM 2019. I think me and Len are talking there, and this is where it all started. So the portable services will soon support also updating configuration with configs. We are working on this right now. But again, more details on our use case tomorrow.
Now 3 scenarios from Flatcar Container Linux. So it's an image-based OS with AB updates for the read-only /usr partition. And our generic image only has this /usr partition. But it's not enough for some cloud environments. They want to have their special cloud vendor tools and service running and so on, which we don't want to be part of the generic image for size reasons, for example. And that's why there used to be a way of putting these on the OEM partition in CoreOS Container Linux. That's where Flatcar comes from. And we always had the problem that these things were not updated. And we wanted to have AB updates as well for the OEM vendor tools. So what we did now is that we migrated them to be systemd sysx images, and now they use version coupling and are part of the AB update mechanism in Flatcar. And the initial version is pre-populated on the OEM partition, and then from there on it's updated, and we always keep 2 around. And the symlink to the current version is set up at boot time. So what we wanted to do from having done the work was to take it further and look into making the whole OS more composable. So as I said, we have this kind of base image, and we have trade-offs what we put in there. We want to be somehow minimal, but at the same time cover many use cases. So how do we do that? Currently, for example, Docker and Containerd are part of the base image. But not Podman and Kubernetes binaries. That is also not there, and users are asking us. So that's why we now plan to provide Docker and Containerd as inbuilt sysx image, like it resides like pre-shipped in our generic OS image. What we gain from that is that you can easily disable it. So all binaries will disappear when you disable this extension. And that makes it easier for people to bring in their own stuff. And we can also add more extensions that are not part of the base image, but downloaded on provisioning time. And also part of this AB update mechanism that we already have for the OEM vendor tool extensions, so that people can say, I want to have the Podman extension, and it gets AB auto-updated as well. And the third use case that we have is user-provided software. So if you don't want to use our Docker version in Flatcar, but your very specific Docker version, for example, or if you want to bring in the Kubernetes binaries, or I don't know what tools you have, the best way to do this is now systemd sysx. So we have one repository, sysx bakery, that has some build recipes with simple scripts to get started with your own sysx images. And we actually have already covered common use cases like a custom Docker version or wasm time or whatever. And so our build scripts are very easy. They basically repackage the upstream binaries. And that means they are not somehow linking against our OS. And that way the user can update them on their own pace. And systemd update makes it easy. And we publish these as GitHub release artifacts, and then they can be consumed through systemd update. Maybe you don't know how this looks like. This is a configuration in systemd update where you kind of say, okay, that's the location where we want to look for things, and there's some kind of manifest file that lists the extensions that are available, and then this current symlink is set up to point to the current version, and then you run systemd update with -c for this Kubernetes component that we defined here to update it. And it's even very easy because you don't have to write this stuff. We provide this whole config file. When you use Flatcar, you can directly source it in the configuration language of Flatcar. Okay.
Also, there's one more use case. We can also use this, as we mentioned before, for initrds. So this was covered before, but very quickly, we have mkosi, which is a tool to build images, OS images, and mkosi-initrd, which can be used to build initrds from packages rather than using Draycat or initrmfs tools. So you can couple this with UKIs that Lennart talked about before, for all the awesome reasons that you already mentioned. And you can use this to extend the initrd in case, again, you have some specific components that you don't want to always ship, like some specific drivers for weird storage, or some specific drivers for GPUs or whatnot. And I already mentioned this, but users can also build their own initrd extensions and sign them with mock for secure boot.
Okay, so yeah, it's quite new, it's already working, you can use it, but there are certain things that we want to see improved. And basically, one important step forward would be to set up the overlay FS already from the initrd for the final system, so that when you have the switch route from the initrd to the final system, all extensions are already loaded. So all files they bring in, for example, for etc or /usr, are already there when the binaries start to run and the services start to run, so you don't have to think about whether things are early enough or not, and when they are not applied because it's too late, then what workarounds you need and so on. So that kind of discussion can be sidestepped by loading things already from the initrd. Then we want to support mutable etc and user and opt mount points, because currently everything is read-only once you load the extensions, so that doesn't work well with traditional Linux distros. And yeah, we want to kind of support modes where you can say, I want to have an ephemeral mode where things can be in RAM, or persistent mode where you write things to disk. I'm not done. So auto selection was also an idea. So currently you have to manage things through a symlink where like you point to the latest version, and auto selection with some kind of .v folder, and a way, for example, where the service unit can say, I want my extensions to be picked up from that folder, latest version if possible, and if somehow I fail as a service unit, then please don't use the latest version, use the previous version again. And we want to enhance the system control try, reload, or restart to kind of also refresh the overlay for the unit mount namespace. And very important is that we plan to use a new mount beneath API in Linux 6.5, so that systemd refresh will kind of erase-free directly replace the extensions, and there's no time where somehow no extension is there because things are unmounted and mounted again currently.
There will be a talk about the new mount beneath API in the afternoon after lunch, by the way.
So basic summary now is that you have these sysext and confext images, and they have many nice use cases. Unique features for adding files to Linux source, for example, and I showed some use cases in Flatcar, and Luca showed them in Microsoft Azure Boost. So you can bundle and update your deployment files easily, and so basically, when you look into the Verity, then somehow your security story can also be a lot better. Okay, questions?
Questions? Many, please.
My question is probably a two-parter. The first thing that you mentioned was that you need to be really very careful with either statically compiling or using a different library path. And one thing in particular is that libc itself may well load DLOpen things, like for DNS lookups and stuff. So this might be also things that you're not aware of that you need to be careful with. And my second thing was, you talked about not depending on libraries from the host, as it were, if you're not certain that you're compatible with that, but also does the reverse apply? If you're a vendor and you accidentally dump a library and you effectively overwrite something of the host OS, is that going to be a problem?
So these are system extensions, right? So they are made for the vendor to deploy. So you're absolutely right. All these food guns are there, but it is a deployment and build problem. We provide the tools to do identification and matching, so this is X level, the version ID, and whatever else, and we help you with that. But on top of that, your build system and your deployment system needs to take care of that. This is not a container infrastructure thing. This is not full isolation. This is extending an host OS, and you need to be able to deal with that.
I just wanted to quickly add to that there's a issue somewhere open on GitHub where people are asking us to add some simple validation of the sysx before we apply them, and that could, for example, mean that if we decide that, yeah, it's overriding a file on the host, we refuse to apply it because that's not how it should be used, and then people can either enable this or disable this or make it a warning or something, and then you're protected a little bit against these kind of mistakes. I mean, these mistakes, I will presume, will happen if bigger installations use this, because then you might have system extensions coming from not the exact same group of people who can avoid this. But yeah, so we probably have this eventually.
Hi. So the power in systemd services mostly, I think, is the condition variables, and are you using that in extensions as well, somewhat, that you can condition on, for example, features in glibc or whatever, where the others services in the dependency tree can say that they have those features, for example? Does it make sense?
Yes, but the answer is no. As mentioned, we have this extension release and OS release mechanism for the matching, and that is all we do. Now, if we want to add more things, pull request welcome. For our use cases for cloud vendors where we ship read-only images, this is enough for us. If people have have other use cases where they want to do more additional, more advanced matching, we are happy to receive pull requests and review them.
Package management system, right? You don't have a way to define, I want to depend on this, and then this extension depends on that, and no, that's not what we do.
One thing I have not seen in any of your examples, I assume you have something there is no specification of processor architectures. No, I can imagine some sysx only contain bash scripts, some may as well contain binaries. And that's also for your GitHub repository of prebuilt ones as well. I assume you have a mechanism to specify CPU architectures?
Yes, there is. It was shown the architecture field. So there is one. You can match either any or the specific architecture, so it is there.
Many immutable distros today use OS tree, and there was no reference to it. So correct. I guess my question would be, what do you think about combining this with OS tree?
So combination, I don't know, but it's a different philosophical thing between OS3 and dm-verity. For us, it's all about establishing trust first, and we do that with dm-verity via the kernel. With OS3, you switch, sideways, left and right, to do a different, like Git-like checkout, and you do not have a way to do that securely with signed payload that are verified by the kernel. It's all done locally, and for us that doesn't work. Now, we haven't really thought about mixing these two things because they are alternatives, and you can pick one, you can pick the other.
But generally it works. You can have an OS tree system, and then you can apply extensions on top. Yeah.
I wanted to quickly answer say more about the condition question that was raised earlier. I think many of the checks that we can do with a condition, like for example, check for virtualization and things like this, I think we probably should have extension release fields for this. And the way we apply the extension release matches should always be graceful, meaning that if it doesn't match the execution environment, we simply skip the image instead of generating an error. Because I want that one of the use cases for system extensions, for example, is this case where, I don't know, a cloud vendor or something can insert an agent this way if they feel like it. Like, for example, I don't know, LXD has this agent that is written in Go, so they could package it up as a system extension and just pass it to us when we boot, and then we actually do like a check like, oh, are we actually in an LXD virtualization? If so, apply it. Otherwise, we just ignore it and just apply the other ones. So yeah, we have this one match for the architecture already that is applied like this, right? Like that it's like if it doesn't match the architecture, we just skip it. And we probably should have the same thing for others as well.
Thank you for volunteering to implement that, Lennart. I'll be reviewing happily your PR after the VPIC one, though. I think there's more. Or do we have time?
No.
We're out of time. Well,
please address your questions in person then.
Thank you very much.
Thank you.